Hi, and welcome to TEMEKO. In this video, we start our next main topic, which is kinetics of a particle. As you can imagine, kinetics is dealing a lot with how the external forces affect the motion of an object. During the next videos, including this one, we are going to cover many interesting concepts related to this topic. We start by discussing about Newton's second law and learning how we can form and utilize equations of motion of a particle in different problem situations. Let's get started. If you still remember from the previous course, we discussed some of the fundamentals of mechanics. During that discussion, we also learned about Newton's laws, of which the second law is perhaps the most important one related to dynamics. Newton's second law states that the magnitude of acceleration which the object is experiencing is directly proportional to the external force F that is applied on it, while inversely proportional to its own mass m. We can represent this law in mathematical expression as follows: F equals m times a. This is also called the equation of motion. In most cases, however, a particle is subjected to several external forces, in which case the equation of motion becomes Fr equals summation of F, which equals m times a, where Fr is the resultant force of all the applied external forces. Notice that we could also write the equation like this: summation of F minus m times a equals 0, where m times a acts as the inertia force vector. Let's move on now to see how we could solve the problems related to the equations of motion of a particle. To apply the equation of motion in rectilinear motion, we can express the equation as follows: summation of fx times I plus summation of fy times j plus summation of fz times k equals m times ax times I plus ay times j plus az times k. If it is possible for us to solve the forces directly from the free body diagram of the particle, which is usually the case in two-dimensional problems, we can also apply the following equations of motion that are in scalar form. In some problems, friction could also be present because of the rough surface that the particle is in contact with. Or the particle could be connected to an elastic spring. In this case, it may be necessary for us to also apply the corresponding equations for the frictional and spring force. For determining the spring force, we can apply the following equation if we neglect the spring's own mass. Fs equals k times s, where k is the spring's stiffness coefficient measured as a force per unit length, and s is the stretch or compression of the spring that is defined as the difference between its deformed and undeformed length. S equals L minus L0. Finally, to solve the kinematic unknowns of the particle, which may be asked, we can apply suitable kinematic equations, which we have learned during the previous videos related to kinematics. Next, let's talk about how to solve corresponding problems related to curvilinear motion. To analyze the movement of a particle on a curved path that is caused by the unbalanced external forces, we first establish the inertial, tangential, normal, and binormal coordinate system at the particle. After this, we apply the equations of motion, which can be written as follows: summation of ft times ut plus summation of fn times un plus summation of fb times ub equals m times at plus m times an, where summation of ft, summation of fn, summation of fb represent the resultant forces in tangential, normal, and binormal directions, respectively. However, since the particle is constrained to move along the certain curved path, we can usually neglect the binormal direction of the particle. In case of the problem asking for us to solve kinematic unknowns related to the particle's motion, we could then use the corresponding equations which are used to describe its curvilinear motion. Hopefully, after watching this video, you have a better understanding of Newton's second law, and you also know how to analyze the motion of a particle in rectilinear and curvilinear motion when unbalanced external forces are applied to the particle. Thanks for watching and have a nice day.